Welcome back, and this is a walkthrough for an exam question based on integration by substitution. If you look at the question, they've given us an area bound between the function and the x-axis, and they gave us some limits. So we have the lower limit and the upper limit, so those will define our definite integral. We've also got a function that involves natural log and an unknown value k, and that is the value they're asking us to find. They gave us the area underneath the curve as 3 units, and it's worth 7 marks. If you want to have a go at it, take a photo, work through it. Otherwise, I'll get started, and it's 1 mark per minute, so we should be able to do this in 7 minutes or less. Let's dive in. Okay, start the clock. We have this area of 3 units, and we have our function here, which we'll need to integrate. Let's just set up the question so we can see what's happening here. In order to do this, we would have to have the lower limit here, e over 5, and then the upper limit here, 1/5 e to the 3 over 2. Now those will likely change when we start this question because we'll need to make a substitution for u. So let's just put this in, and I said if you haven't seen this in the description, then I would recommend you watch those videos first because this is a more advanced version of the substitution. We can't integrate that, right? So what we'll do is we'll let u equal natural log 5x, okay? And when I differentiate du with respect to x, we will get 1 over 5x times by the derivative of this bracket here, and that will be 5. So therefore, then these 5's will cancel out, just leaving us with du dx is equal to 1 over x. Now, what I want to do is I want to try and make this thing here look like what we have in terms of x. So there's a little bit of moving around. So what would happen is imagine I move this dx over to the right here, and then we move this kx to the right here and just put 1 over that, right? So if we can switch out this, right, with something in terms of du, that will be a good step to make. So here we go. We're going to times both sides by dx, right? And then we want it to look exactly like this, remember, that I've just circled. It isn't quite right, so we need to times both sides by 1 over k. So we times 1 over k, that'll be du, and then we times 1 over k here, we're going to get kx dx. Now this is great because now what I've circled in pink is exactly the same as what we have over here in white. So what we'll do is we will switch it out with this here, this 1 over k du. So I'm going to rewrite the problem, but in terms of u now. So a, now I know the a is 3. We'll come back to that, okay? And I will leave the limits off for the moment. We know that this value here, this natural log 5x, was my initial substitution. That was u, right? So u is going to go on the numerator here. The 1 over kx dx gets switched out for 1 over k du. So I'm going to put du here. Sorry, there is a denominator, but I'm going to put the 1 over k on the outside there. Now, I want to change these limits. So let's go ahead and focus on this lower limit first. So we've got e over 5. Now, when we do e over 5, we need to change it in terms of u. So what we'll do is we'll do that up here. So we have u is equal to natural log of 5 times e over 5. Now, when we do that, those 5's will cancel, and then you left with like natural log of e. And natural log of e is just 1, because it's what do you raise the power e by to get e. Remember, natural log is log to base e. So it's what you raise the power e by to get e, and the answer of that is simply 1. So that lower limit is going to change to 1. So I'll just go down here, and I'll just put that in yellow, so it's 1. Now let's go ahead and do another limit. So let's have a look at this 1/5 e to the 3 over 2. 1/5 e to the 3 over 2. So I'll just erase this here, and I'll do the same again. So we want to know what is u if natural log is 5 times 1/5 to the e to the 3 over 2. And conveniently, the 5's will cancel again with the 1/5, leaving us with natural log e to the 3 over 2? And the answer to that will just be 3 over 2, because the base of the log is e. What do we raise e by to give 3 over 2? So that will be 3 over 2. So therefore now we have our upper limit, 3 over 2, and we're ready to start substituting some values in. In the question, they told us this a value was an area 3. So we've got 1 over k of, and let's have u squared over 2. And the upper limit was 3 over 2, and the lower limit 1. And that's all with respect to du. So that's fine. We can substitute all of that in now. So 3 equals 1 over k. We've got 3 over 2 squared, so that'd be 9 over 4 over 2. Then we're going to subtract, we substitute 1 into that now, so it will just be subtract a half, close brackets. Well, 9 over 4 over 2 is 9 over 8, so we get 3 is equal to 1 over k, 9 over 8 minus, now let's put this in terms of 8, so we can times top and bottom by 4, so that would be 4 over 8. And we're getting close to the end here. So 3 equals 1 over k. This is 5 over 8. Let's times both sides by k. So we'll put the k on the left-hand side and bring the 3 down. So it'll be 5 over 24. And that is the answer. Stop the clock. So normally I'll just switch off here, but basically I think the difficulty in this question was that the things were not in terms of like integers. So we had this e. Also, they relied on your rules of logs here and substituting the values into that and understanding natural log. So I do think there's many steps there, and that makes that quite a tricky question. But let me know in the comments below. Otherwise, I'll see you next time. Good luck. So, integration by substitution. Would you like me to do more questions? Did you find this one easy or difficult? Let me know in the comments below. Don't forget to like and subscribe to the channel. I'll see you next time.